This section is 6.6 and it covers complex numbers. Complex numbers are actually written like this. A plus bi, whereas the I is the imaginary numbers. So you can break these down. You have one part that's real numbers, and then you have imaginary numbers. And imaginary numbers are any time that you have a negative number inside an even root. And to get the negative out, it becomes an I. So even roots with negatives underneath the radicand, or in the radicand, produce, to pull it out, you have to have an I. It makes an imaginary number. So, let's look at this. We have the square root of -4. We can pull the I out, or the negative out, as an I. And then we can do, okay, the square root of 4, which is 2. Or you can write it, the I behind. Okay? Now we have this equation, or this problem, that they want us to simplify. Okay. They want us to put, they want real parts and imaginary parts. Okay? So to do that, what we're going to do is, first we need to get these things out of the grouping. Anytime you see parentheses, you know you're going to distribute stuff. There's a 1 in front, and anytime you have a positive one that distributing, you can get rid of your parentheses. It's not going to change it. So what we have is we have 3 plus 2i, and this is positive as well, so we can drop our parentheses and have 4 minus 5i. Now if you look at this real carefully, we have like terms. We have this 3 and this 4, and we have this imaginary part and this imaginary part. So let's add our real parts together. Our real parts are the whole numbers. We have 4 plus 3 is 7. And then we have our imaginary parts, which is positive 2 minus 5, which is minus 3i. In this case, the I just kind of goes along like a tag, like our variable does. So this would be our when we simplify this, we get this. So on this, our real part would be this, which would be 7, and the imaginary part would be the -3, because the -3 is in front. Now we're given this equation, or I say equation, but it's not. It doesn't have an equal sign in it. And it wants us to label the real part and the imaginary part. The real part is the part that doesn't have the I. That's the real part. So the real part is 3/4. Our imaginary part is the part with the I, and it would include the sign. So our imaginary part is a -2/3. Now when they're asking for the parts, they don't need the I with it. It's just what is in front of it. So this would be our answer. Okay, we have a quantity of square root of 5 plus 6i plus 7 minus 2i. Okay, first thing we want to do is get rid of our grouping symbols. We're looking outside of them, and both of them have positive numbers. So we can get rid of them. We don't have to do anything but just write it without, because they're adding. They're both positive, so it's not going to change the signs or anything. Now we're going to look at our real parts. Our real parts on this one is everything that doesn't have an I in it. This doesn't have an I, and this doesn't have an I. So we're going to group those together. We have square root of 5 plus 7, and then we have our I's. And since they're kind of like terms, we can add them together. We get plus 4i. And that is what is considered standard form. Okay, you have your real numbers separated from your imaginary numbers. Now let's do -1 plus 2i minus the square root of 10 minus I square root of 7. Okay, first thing we want to do is get rid of our parentheses. This has a positive out in front of it, so it's not going to change anything inside, so we can write everything the same. This, however, has a negative in front of it, so we are going to want to distribute that negative through. So negative times positive is a negative. Negative times a negative is a positive. Now we're looking at what is our real parts, what is our imaginary parts. So the imaginary parts are easy to find because they're all the terms that have the I's in them. Those are the imaginary parts. But we want to list the real parts first because in standard form, real parts are first. So we're going to have -1 minus the square root of 10, and that's one group. And then we have our I's are going to, we have 2i plus I square root of 7. Now, when you have two things that have an I in them, we're going to factor that I out. Okay? So on this one, we have both positives here, so we're going to have a positive I outside. We have 2 plus the square root of 7. And then this part. So our real numbers, in this case, real, and our imaginary. Our real is this -1 minus square root of 10. And then our imaginary is 2 plus square root of 7. Now, in the Hawk system, they have the I behind. But you should be able to write it either way. But while you do your homework, it would probably be, it's very possible that it might count it wrong if you put it in the front. But either one is correct. The Hawks system will take this one though. This again is standard form. The reals are here, the imaginaries are second, and if you have, you're only going to have one I outside. -8 plus -25 minus -9 plus -81. Okay, first we're going to have to deal with our I's. Well, we don't have any I's, do we? But we do have negatives inside even roots. So that's where our I comes into effect. So we're going to have -8 plus I. And we could, if you wanted to at this point, go ahead and simplify that even more and pull the 5 out. But just so you can see all the steps, I'm going to go ahead and do this. The negative comes out as an I. and you have square root of 81. Now we're going to take care and make sure we simplify these. So we've got 8 plus 5i, because 5 times 5 is our pair. And then we have subtract negative 9, and 9 times 9 is 81, so we have plus 9i here. Now we're at the same stage that we were in some of the problems that we've already accomplished. We want to get rid of our parentheses. This has a positive out in front, so it's not going to change anything inside. This one has a negative out in front, so we're going to have to change our signs to distribute that negative through. Negative times negative is positive. Negative times positive is negative. Now you're going to look and say, oh, I need to find my i's. So by real numbers, I can actually combine those to be a 1, because negative 8 plus 9 is 1. And then I have positive 5 and negative 9, which gives me negative 4i. And that would be my standard form. Okay. Now let's make it a little more complex with a little more information. We have negative 9 minus I minus 8 minus 7i minus negative 7 minus 8i. Okay. We can't combine anything inside our terms, so let's look outside and get rid of our parentheses. This is positive, so we can just write everything the same. We have a negative 1 timesing this, so all of our signs inside are going to change. This is positive, so it's going to become negative 8. This is negative, so it's going to become positive. Same thing here. We got a negative distributing through. It's going to change our negatives to positive signs. Okay, now let's find all our imaginary numbers. We've got this one, we've got this one, and we've got this one. So let's do our real ones first. We've got negative 9 minus 8 plus 7, which would be negative 10. Then we have negative, these are all like terms because they all have an I on them. So we have negative 1 plus 7, which is 6, plus 8, which is 14. And since we cannot, they're both different. It's like having an X to Y here. They're not the same terms, so we can't combine those, and that's as far as we can go. Okay, let's try this one. Square root of 6 plus I square root of 3 plus 4 plus I square root of 5. Again, we can't do anything inside because they're different terms, so we look outside. They're both positive, so we could just rewrite this without the grouping symbols because the positive ones multiplied through will not change anything inside. So now we have to identify what's real and what's imaginary. Again, the imaginary is easy to find because they have the i's. So now we want to combine our real terms. These terms, we can't add those together because, remember, that radical we can only add if they have the same things. The same radicand, and the radicand and the root has to be the same. So that's going to be our real part. And over here, we can't really combine those two because we don't have, the radicand inside is not the same. Yes, they're both to the same index, but they have to both be the same. So we can't add those together. But we could, what we'll do is we need to pull the I out because they both have an I in common. So if we pull an I out, and they're both positive, so we're going to pull out a positive I. What we have is a square root of 3 plus a square root of 5. And that's our answer. And that is in standard form. Standard form has the real parts first and the imaginary parts second. Alright, we have 4 plus the square root of negative 36 plus negative 8 plus negative 36. Alright, the first thing that we want to do here is we want to simplify what's inside our radical signs. So we have 4 plus, the negative will come out as an I, and 6 times 6 is 36, so we'll have a 6 out here. And then we're going to plus negative 8. The negative comes out as an I. And then 6 times 6 is 36. So we have 4 plus 6i. I'm going to rewrite it just a little bit. And we're going to have minus 8 plus 6i. Find our imaginary parts. We'll do the real ones first. 4 minus 8 is negative 4. And then we have, now these are like terms because they're both i's, and it's 2 6, so we have 12i. And that is our answer. Okay, now we're going to actually get into an equation. It's asking us to solve for x and y. What you need to remember is x stands for our real numbers. Our y always stands for our imaginary numbers. That makes it a lot easier. So here's our equation. We have 18x plus 8 over 19i equals 8 plus 3yi. So what we're going to do is, what we need to do is we have to find our x's and find our y's. Or, yeah, what's our x? We have an x here. And if you notice, it's with the real parts. So here's an x with the real part, and here is the real part over here. And our y is with our imaginary part. Those are not that much different. Okay, so what we're going to do is we're going to write two equations to find out what they are. So our x's, or our real parts, is 18x equals 8. And keep track of your equal sign where it's at. And our imaginary part is 8 over 19i. And then we have our equal sign, 3yi. Now we're going to solve. The real part, we're going to divide by 18 because we want to know what x is. And x is, we could divide by 2 for both of those. So we get 4 over 9 for our x. And for our y, we want to solve for y, so we're going to get rid of the 3i, which those cancel. 3i. And really, when you have a fraction divided by a whole number, you're really going to multiply by its reciprocal. So this one ends up being y is 8 times 1 is 8, and 19 times 3 is 57. And it does not simplify because 8 doesn't go, and 56 is the even one. So our x is this, and our y is that. So just remember, you want to split apart the real part from the imaginary part and just treat each as their own special equation to get your answers. Let's look at this one. It is an even root, and the only way to get the negative out is to make it imaginary. So we're going to have I times the square root of that. So we could come over here. 2 won't go into it. 3 won't go into it. 4, no. 5, no. 6, no. 7, no. 8, no. 9 doesn't go into it either. 10. Well, 11 doesn't go into it. 12. 13 is another prime number. Doesn't go into it. 14. 17. 17. Will 17 go into it? Nope. Really, when we take the square root of that, it gives us the approximation of 20.22, and there are no prime numbers under 20 that go into it. So I have to conclude that 409 is a prime number. So our answer would be I square root of 409 for the answer for that one. Now let's do the square root of negative 245. The negative comes out of as an I. Then we need to see if we can find 5 goes into that. 4, 24, 9, and then we have 7 and 7. So we've got a pair of 7s that will come out. So we have 7i square root of 5. And that's as simple as it's going to get. So that's our answer. Now we have, you're going to see problems like this as well, where you have square root of 14 minus square root of 14i, and all this is both 16, and they want the real part and the imaginary part. Okay, so what you have to recognize is anytime you have 2 terms on the top with 1 on the bottom, you can separate those, and where you actually have 14 over 16 minus square root of 14 over 16i. Or I think Mrs. Malone just circles them like this. See, which it means the exact same. So we can't reduce this because one's inside the radical, one's outside the radical. So we're done. The real part is square root of 14 over 16. And if you look at this one, we're done as well because we can't reduce it because one's inside, one's outside. So here we have negative 14 over negative square root of 14 over 16. Looks hard, but it's easier than what it looks like. Let's do another lengthy one. Negative 7 minus 2i plus negative 3 minus 4i minus negative 3 plus 6i. Okay, first step is to simplify within the parentheses. Since we can't do that, we have to look outside the parentheses. And since these are positive numbers, nothing inside is going to change. So we can write them without the parentheses. However, this negative, we're going to end up distributing a negative number through there. A negative 1. So that becomes positive 3 and that becomes negative 6i. So now we look for all our i's. And if you really look at it, we have a positive 3 and a negative 3 here. So those cancel each other and all we have left is the negative 7 for the real numbers. And for our imaginary numbers, we have negative 2, negative 4, and negative 6, which I believe that's negative 12. I. And we're done. Let's do another one where we're finding the real and the imaginary in a fraction. Here's the real, here's the imaginary. What are they going to be? Okay, we can split them up. So we get 14 over 12, and then we get negative square root of 17 over 12. This is the real. This is the imaginary. These are both outside, so we can reduce those. We can take, what, a 2 out of each one of those? So we get 7/6. So that's our real part. However, we can't reduce this one because one's inside, one's outside. So we have to leave that the same. I think we only did one of these before, so let's go ahead and do one more where we're giving the equation and they want us to find x and y. Again, x's, and if you forget, it's not that hard. All you have to do is look at your problem. X's are with your real numbers and y's are with your imaginary numbers. See? So we're going to take our real numbers and make them in an equation. And then we're going to take our y's and put them in an equation. All right. So, solve for x. If you divide by 2, you're going to get x. Can we reduce anything here? No, we cannot, because one's inside a radical, one's not. So our answer for this x is a negative square root of 2, or square root of 15 divided by 2. And our y, to get y by itself, we divide by 16i. And we're going to divide by 16i here. The i's will cancel. Dividing by 16 is the same as multiplying by its reciprocal, which gives us negative 7 over 16 times 15 is 240. The i's cancel, so that's all that's left. It's just that number. Real numbers, imaginary numbers, or real part, imaginary part.